I'm here to tell a user story about critical infrastructure resiliency. The critical infrastructure is the industrial base on which the competitiveness and security of a nation are dependent. The current state of a nation's critical infrastructure is at risk. The internet has become the central nervous system of a nation, both public and private. A nation's critical infrastructure continues to be vulnerable to natural disasters and cascading cybersecurity attacks. In fact, software has become the critical infrastructure within the critical infrastructure, said Alan Salisbury of the Center for National Software Studies. The overall demonstration of the mission to achieve critical infrastructure resilience is being initiated in three parts: the composition of a user story and the subject of today's presentation, the preparation of a software systems architecture, and the project plan in terms of principles and foundations in the way of working. It is in the context of software engineering methods and technology, SEMAT, and its Essence Kernel, framed by Ivar Jacobson, that the user story on the critical infrastructure resilience is being demonstrated. While the critical infrastructure being framed is influenced by thinking in the United States, nations around the world share many of the common challenges discussed and may find the approaches and prescriptions useful. The internet has become the central nervous system of the nation, both private and public. It is controlled and driven by systems of systems and their underlying complex, large-scale, real-time software systems. Private industry controls 80 to 85% of the critical infrastructure. Consequently, private industry must adopt resilience as an essential ingredient of competitiveness, with the expectation of boosting brand value. The critical infrastructure protection (CIP) model is insufficient. In addition to CIP, a critical infrastructure resilience (CIR) model needs to be adopted. We need to move from the static lock and chain protection beyond the combination lock to the strategy of a chessboard with moving parts capable of anticipating, avoiding, withstanding, mitigating, and recovering from the effects of threats and vulnerabilities. We need to shift the locus of control for the nation's cybersecurity from protection to resilience. The Timex slogan, "Take a licking and keep on ticking," demonstrates resilience in the absence of protection. If we want to avoid taking a licking, we need to have both protection and resilience. The critical infrastructure is composed of the numerous industry sectors that do the heavy lifting. Some key sectors are listed here. The operations within the industry sectors of the critical infrastructure are diverse and complex. These industry sectors comprise an accidental system of systems that intersect operationally without a plan and design in advance. Each sector system was constructed within its own context and culture. In operation, these sector systems may inadvertently impose their own context and culture on others and clash with uncertain and unintended operational results. Industry sector practice varies widely in their domain engineering approaches, resulting in diversity in architecture, models, and patterns, including their representation. Formality within an architectural framework facilitates the imposition of distributed supervisory control, interoperability, and operation sensing and monitoring protocols. Industry sector maturity in management and engineering processes varies widely, resulting in diversity in configuration management, frequency of release, conformance to requirements, and traceability among lifecycle artifacts. Strong code management practices facilitate reconfiguration and reconstitution. Industry sector practice varies widely in fielding and operating practices, resulting in diversity and accountability and control, supply chain management, civility and pushback, and willingness to expend off-the-clock effort. Exercising strong control over the workforce facilitates business continuity and survivability. Industry sector impacts from government regulation vary with respect to export control, tax policy, intellectual property, privacy, and antitrust litigation. Exercising strong government control facilitates compliance for the benefit of the commons at the expense of initiative for the self-interest. Industry sector public expectation and confidence vary with respect to trust, loyalty, and satisfaction. The financial and medical sectors depend on public trust. The electrical and telecommunications sectors depend on customer loyalty and satisfaction. One respected researcher seemed to concede the high ground of resiliency, that is, avoidance, in associating resilience with the Timex slogan, "Take a licking and keep on ticking." The question then becomes, what perimeter is being secured? In protecting a network node or a physical facility in a geographic region, each node or facility is to be protected and made survivable. In achieving resilience, propagation and cascading effects across the network and region must also be curtailed. This is made difficult by the context and culture challenges of the industry sectors within the critical infrastructure. The capabilities needed to impact cross-cutting issues cannot be expected to evolve in a loosely coupled environment. They must be holistically specified, architected, designed, implemented, and tested if they are to operate with resilience under stress. A management, process, and engineering maturity framework is necessary to advance the assurance of software security, business continuity, system survivability, and system of systems resiliency capabilities. Intelligent middlemen possess the broad range of hard and soft skills spanning the cultural, ethical, legal, business, process, management, and engineering dimensions needed to meet the challenges of the critical infrastructure in anticipating, avoiding, minimizing, withstanding, and recovering from cross-cutting effects and to impede the emergence of propagating and cascading effects. The intelligent middlemen are positioned at the center of things and serve as the traffic cop for identifying and driving resolution of cross-cutting issues. From this vantage point, the intelligent middlemen are able to obtain superior situation awareness. For example, they ensure that recovery time objectives are coordinated, interoperability protocols are followed, distributed supervisory control functions are coordinated, and operation sensing and monitoring functions are applied. Beyond just the critical infrastructure, the Homeland Security Information Network, shown here, begins to capture the broader demand for resiliency. Here we need to strike an intelligent balance between two extremes, where no one knows everything and where everyone knows everything. We need to adopt the intelligent middleman approach, where highly qualified middlemen know as much as possible, know how to acquire additional information, know how to connect the dots, and know how to act on what they know. Of the 36 entries comprising the communities of interest shown here, how many do you think are secure? Can anyone name one entry that is secure? Now consider the Homeland Security Information Network itself. To what extent is the network resilient? Just as important as the answer to the question is the means by which you arrived at the answer. How does one assess the assurance of resiliency? The intelligent middleman job specification is described as follows. Number 1, the intelligent middleman must be educated, trained, and in possession of the broad gauge experience to fill the role of Chief Critical Infrastructure Resilience Architecture and Operations Engineer. Number 2, as Chief Engineer, The intelligent middleman must be educated and trained in the prerequisite essentials of both systems engineering and software engineering, and have experience in how things are built and how things are used, from architecture through operations. Number three, as a boundary spanner, the intelligent middleman must understand and be capable of planning and exercising command and control of the critical infrastructure under stress. Number four, specifically, the chief engineer must manage the state transitions associated with its electrical grid and data transmission infrastructure, interoperability and information sharing protocols, cybersecurity framework, law enforcement and emergency services, sector coordinated recovery time objectives, cascade triggers, digital situation awareness, information and data recovery protocols, distributed supervisory command and control protocols, and supply chain logistics and risk management. Number five, the intelligent middleman must maintain the foremost focus on the goal of anticipating, avoiding, withstanding, mitigating, and recovering from the effects of adversity, whether natural or man-made, under all circumstances of use. There exists a need for a means to harmonize the diverse and complex operations within the industry sectors of the critical infrastructure, which comprise an accidental system of systems that intersect operationally without a plan and design in advance. Each sector system was constructed with its own context and culture. In operation, these sector systems may inadvertently impose their own context and culture on others and clash with uncertain and unintended operational results. The maturity framework for assuring resiliency under stress provides that means and delivers value through management, process, and engineering capabilities and solutions that address security, continuity, survivability, and resiliency. The system perimeter focus areas include commitment to a business case, security in depth, business continuity, and survivability. The essential focus areas needed to extend this perimeter to the system of systems context needed to demonstrate resiliency include coordinated recovery time objectives, interoperable information and data exchange, operation sensing and monitoring, distributed supervisory control, and information and data recovery. To achieve maturity in the assurance of resiliency under stress, the enterprise must satisfy the goal-based argument at each level. The objective of the maturity framework for assuring resiliency is to drive the business case and enterprise commitment towards the assurance of software security, business continuity, system survivability, and system of systems resiliency. Level 1 is a state of affairs where there is inability to advance and exhibiting evidence of apathy, denial, management inaction, and lack of engineering know-how. The Level 2 goal is to demonstrate commitment to security assurance through strategic management, internal processes, and defense in depth. How is commitment achieved, quantified, and expressed? Commitment is achieved by coping with the stresses and conflicts between competitiveness and security. Commitment is quantified by calculating security return on investment in terms of preparation and incident costs, cleanup costs, lost opportunity costs, and reconstitution costs. Commitment is expressed through a Chief Security Officer leadership program and security assurance operations. The Level 3 goal is to demonstrate business continuity assurance through compliance management, external processes, and product engineering. How is business continuity achieved? Business continuity begins by focusing on supply chain management, including global sourcing and open source. It extends to regulatory compliance and aspect oversight and assessment. Business continuity culminates in the systematic crisis management steps of prevention and response that sustain stability or result in a return to stability. The Level 4 goal is to demonstrate the achievement of system survivability through the management of faults and failures, sustainability processes, and reliability, maintainability, and availability engineering. Central to system survivability is resistance and recognition of cyber attack or cyber threat, and the recovery and reconstitution of enterprise operations following. The Level 5 goal is to demonstrate the achievement of systems resiliency through the management of external interactions and dependencies, the control of distributed supervisory processes, and the practice of next-generation software engineering. A defined engineering challenge of adopting resilience throughout the nation's critical infrastructure is needed. The recovery time objectives among industry sectors must be coordinated. Interoperability of information sharing and platform operations must be assured. Distributed supervisory control protocols must be in place. Operation sensing and monitoring must be embedded. And digital situation awareness must be enabled. The systems of systems architecture and engineering operational concept underlying resiliency under stress is shown here. Interoperability, operation sensing and monitoring, and coordinated recovery time objectives form the foundation for digital situation awareness. Intelligent middlemen, response tactics, the identification of cascade triggers, and information and data recovery tactics form the ingredients for distributed supervisory control. A nation's critical infrastructure is composed of systems. Resilience in the critical infrastructure can be reasoned about using the systems coupling diagram framed by Harold Bud Lawson. The model is composed of a situation system, an interacting respondent system, and systems assets, instantiated for use as services as needed by the respondent system in its interaction with the situation system. The systems coupling diagram is a template and pattern for software systems architecture of all kinds. A resilient software system architecture based on the systems coupling diagram would be capable of delivering a resilient critical infrastructure system of systems. In accordance with the systems coupling diagram, the software systems architecture for critical infrastructure resilience calls for the following allocation of control, functions, and persistent data and assets. The situation system is populated with the man-made critical infrastructure sectors and the intelligent middlemen control node. The respondent system is populated with the Level 5 System of Systems Resiliency Engineering mission focus areas intended to interact with the situation system and its intelligent middlemen in anticipating, avoiding, withstanding, mitigating, and recovering from the effects of adversity under all circumstances of use. The system assets is populated with the Level 2 through 4 facilities focus areas and their services to be instantiated by the respondent system in its interaction with the situation system and its critical infrastructure sectors. More specifically, the critical infrastructure situation system is composed of utilities and energy, banking and finance, medical systems, transportation, and telecommunications, as well as public health, food and agriculture, federal agency, regional response, emergency response, and intelligent middlemen control node. Each sector of the situation system is composed of the control, functions, and persistent data and assets local to the sector. The respondent system is engineered as a system of systems architecture composed of coordinated recovery time objectives, interoperable information and data exchange, operation sensing and monitoring, digital situation awareness, distributed supervisory control, and information and data recovery. The situation system is composed of the control, functions, and persistent data and assets of the global system of systems. The system assets include services and facilities to be instantiated by sector, including enterprise security commitment management services, enterprise business continuity services, and system survivability engineering services. The system assets is composed of the facilities and service assets made available to situation system and its sectors by the respondent system. Whether you establish criteria at the beginning of a project or not at all, there exists industrial strength objective criteria for learning the status of a project and pointing the way forward. These criteria can be found in the Software Engineering Method and Theory, SEMAT, formulation, and its Essence Kernel. The essence and common ground of software engineering and a major object management group, OMG, standards process. The customer space is framed by stakeholder shared vision for a well-conceived value proposition for the opportunity with convincing and consequential outcomes. The solution is bounded by stakeholder agreed-to requirements and user stories and a software system architecture that facilitates a stable and operational software product. The endeavor's work is performed by a well-selected and ready team and a way of working based on established principles and foundations. As the twig is bent, so grows the tree. So to get your project off on the right foot, expectations should be set and evidence should be sought on the following assertions and principles based on the following alpha state checkpoints. Number 1, stakeholders are in agreement and share a vision for the project. Number 2, an opportunity value proposition has been established and there is stakeholder shared vision for achieving it. Number 3, requirements or user stories are coherent and acceptable, and there is stakeholder shared vision for them. The software system architecture is selected and comprises a domain-specific architecture to guide software system implementation, and the software system implementation is made ready and operational with no technical debt. Number 5, the team operates in collaboration, shares a vision for the project, and is ready to perform with respect to shared vision, software engineering process, software project management, software product engineering, operations support, and domain-specific architecture, processes, methods, and tools. Number 6, the way of working by the team has established foundations for software engineering process, software project management, and software product engineering and operations support. Number 7, the work is started only when all is prepared, including coherent requirements and acceptable user stories, stakeholders in agreement, and an established foundation for the way of working. All work products are prepared and inspected in accordance with a defined standard of excellence, assuring completeness, correctness, and consistency. Certain selected milestone states serve as indicators of project success. When completion of these states and their stages is neglected or postponed, the outcome of the project is placed at risk. The figure presents the selected milestone states critical to success on a project. What is needed is a kickoff commitment for the critical infrastructure resiliency opportunity identified and selection of the team. Stage 1, pointing the way, has been initiated with requirements bounded and a software system architecture selected. Stage 2, digging in, is awaited with the need to articulate the value proposition for each industry sector, coupled with coherent requirements to deliver on it, and established foundations for the way of working. Stage 3, major milestones, with stakeholders in agreement, accepted requirements, and work started by the team performing the initial release. Stage 4, locking in the gains, with stakeholders satisfied with deployment and the team performing incremental releases with work that is under control. Stage 5, preparing to stand down, with stakeholders satisfied in use, benefits of the opportunity value proposition being accrued, and the team working well in performing the final release. Project termination, with retirement of the project and work that is closed. So there we have the user story for critical infrastructure resiliency. Resiliency is the high ground. Claim it. Make your move. How many people are ready to take the next step? Are there any questions on the user story, the intelligent middlemen, resiliency maturity model, the system of systems architecture and engineering coupling diagram, or the SEMAT Essence Kernel and its way of working and selected milestone states? Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.